In the present video, we will solve the GATE 2025 problem of the two price break model. Let's see the problem. A company uses 3000 units of a part annually. The units are priced as given in the table below. It costs 150 rupees to place an order. Carrying costs are 40% of the purchase price per unit on annual basis. The minimum total annual cost is dash rupees. Let's see the solution. So first write down the given data. A company uses 3000 units of a part annually. So it is given the annual demand. Let's consider capital D equal to the 3000. The units are priced as given in the table below. So here there is the two price breaks. So for the up to the quantity 499, it is the 9 rupees, and 500 to 999, it is the 8.5 rupees, and 1000 or more, it is given the 8 rupees. So there are the two price breaks. First break at the 500, another break is at the 1000. So let's consider B1 quantity is the 500 and B2 quantity is the 1000. And it cost 150 rupees to place an order. So it is the ordering cost. Let's consider C0 equal to the 150. And carrying cost are 40% of the purchase price per unit on an annual basis. So it is the, let's consider small r equal to the 40%, so which is the 0.4. Then we have to determine the minimum total cost. We know the minimum total cost. We have to determine total cost. We know that one, the total cost equal to the purchase cost plus ordering cost plus carrying cost. So let's see the solution. Step 1 is consider the lowest price C3 and determine the Q3 star by using the basic EOQ formula. So here given the three prices. One is the C1 9 rupees and C2 is the 8.5 and C3 is the 8 rupees. Among these three prices, C3 is the lowest price. So with respect to this unit price 8 rupees, we have to determine the EOQ value. So let's consider at the C3 price, EOQ value is the Q3 star. So Q3 star will become the root of 2D C0 by CH, which is we can be rewrite as root of 2D C0 divided by C3 into R. So here C3 equal to the 8 rupees and R equal to the 0.4, C0 equal to the 150 and D equal to the 3000. Then substitute all the values, we will get the Q3 star equal to the 530.33 units. But at the unit price of the 8 rupees, we have to order quantity is 1000 or more. So which is the not feasible. So anyhow here we have to check the two conditions. So first one is the if Q3 star is greater than or equal to the B2, then place the order for quantity of size Q3 star and obtain the discount. If Q3 star less than the B2, then go to the step 2. So here Q3 star equal to the 530.33 and B2 value is the 1000. So 533.33 is less than the 1000. So which is the, so satisfy the condition B. If Q3 star is less than the B2, then we have to go to the step 2. So now we have to go for the step 2. Step 2 is calculate Q2 star based on the price C2. So here C2 value is the 8.5. So with respect to this cost, we have to determine the EOQ value. That is we are considering the Q2 star. Then Q2 star equal to the root of 2D C0 by CH. This is we can be rewrite as root of 2D C0 by C2 into R. So C2 value is the 8.5, R equal to the 0.4, D is the 3000, C naught equal to the 150. Then substitute all the values, we will get the Q2 star equal to the 514.49. So here observe, so at the price of the 8.5 rupees, we have to order the quantity in between the 500 to 999. Here value is the 514.49, which is in between the 500 to 999. So this unit price, 8.5 unit price is the feasible price. So now we have to determine the how much quantity we have to order, whether we have to order the Q2 star or maybe the 1000. Okay, so here also have to check the two conditions. Compare the Q2 star with B1. If Q2 star is lies between the B1 to B2, which means B1 less than or equal to the Q2 star is less than the B2, then compare total cost with respect to the Q2 star quantity and total cost of the B2 quantity. Second condition, if Q2 star is less than the B1, then go to the step 3. So here Q2 star value is the 514.49, which is lies between the 500 to 999. So then we have to compare the total cost of the Q2 star and as well as the B2 quantity. First we determine the total cost for the quantity of the Q2 star. So we know the total cost equal to the purchasing cost plus ordering cost plus carrying cost. So purchasing cost is the demand into unit price. Here Q2 quantity, which is the 514.49. So for this quantity unit price is the 8.5. So in this regard, purchasing cost equal to the demand into the C2 price. And ordering cost, number of orders. So number of orders D divided by Q2 star into ordering cost plus carrying cost 1 by 2 into Q2 star into RC2. So then total cost for the Q2 star quantity, which is equal to the 3000 into 8.5 plus 3000 divided by 514.49 into 150 plus 1 by 2 into 514.49 into 0.4 into 8.5. Then total cost for the Q2 star quantity, which is equal to the 27,249.28. So next we determine the total cost for the B2 quantity. So here B2 quantity is the 1000. So for the 1000 or more quantity, you have to consider the unit price is the 8 rupees, which is the C3. So in this regard, so purchasing cost for the B2 quantity, it is the 3000 into 8 rupees. So mostly we are doing the here only mistake. Most of the times we are considering the here also 8.5 C2 price. So be careful. So for considering the unit price, we have to check the quantity. Okay, anyhow, so total cost for the B2 quantity, which is equal to the 3000 into 8 plus 3000 divided by 1000 into 150 plus 1 by 2 into 1000 into 0.4 into 8, which is equal to the 26,000. So 050. So among these two prices, so minimum total annual cost, which is equal to the 26,050 rupees for the quantity of the B2, that is the 1000 quantity. So this is the solution, and thank you.